Morning, guys. Actually, today we're going to be doing the quotient rule, 3.3b. But before we do that, let's just recap what we did on the previous lesson. We did the product rule. So if I was taking the derivative where u and v, okay, it's understandable, u and v are functions in terms of x. U and v are functions in terms of x. So I have a function of x times another function of x. My derivative, how I usually do that with the product rule, is I go through my head and I say derivative of the first function times the second function plus the derivative of the second function times the first function. That is just the way I organize that in my brain. So then when I'm looking at this example, I'm like, okay, there's my first function of x, here's my second function of x. So my y prime is going to be the derivative of the first function of x, 14x, times the second function, plus the derivative of the second function is negative sine x, derivative of the second function, times the first function, which would be 7x squared. And then, because I'm a little OCD about this, I would just rewrite it 14x cosine x minus 7x squared sine x. Please understand, if you put this in your calculator, I would really not doubt if it factors it, because sooner or later we're going to be setting these equal to 0, which means we're going to want to be able to factor these. There's a greatest common factor of 7x in each one, so I could also write this as 7x times 2 cosine x minus x sine x. Okay, that also would be an acceptable derivative. Right now, either one of these two is perfectly fine. Okay, but what we're going to do today is we are looking at the quotient rule. So just like we did the product rule, okay, typically most people are going to look at this and they say, oh, I just got to take the derivative of the top and divide it by the derivative of the bottom. The sign is cosine. So yeah, it's going to equal 3 over cosine x. And by the way, the 3.5a worksheet, no, it wasn't that one, sorry. It was the other one. When I was in the Google Meet, I said, you guys will not know how to do number 6 and 7. Okay, this is how everybody that did number 7, understand that's wrong, okay? So what we're going to do is we're going to look at a quick pattern here, and we are going to figure it out, and we're going to do the same thing as we did on the product rule. We're going to pull up our calculator, and I want to know what the heck is the derivative in terms of x of 3x over sine x. So I'm just going to enter that, and I'm going to say, bingo, it's right here. Now, I want you to understand, your calculator is always going to write things in alphabetical order in terms of sines and cosines and things. It's just kind of weird. And notice it's factoring out a -3. So technically, how I want you to picture this is first want you to see it's -3x cosine x plus 3 sine x over sine squared x. Now, before we go there, okay, because it's written in alphabetical order, and I just want to point a couple things out to you here, is interpret this as 3 sine x minus 3x cosine x over sine squared x is how we're going to look at this now, okay? This is exactly how I want you to do it. And we're going to look at that. We're going to interpret the calculator as this for a particular reason. So I'm going to get rid of this for a second. And I'm going to come back to my notebook page here. And we're going to say that that's wrong. And the correct answer, we just said, was 3 sine x minus 3x cosine x over sine squared x, okay? And now what I want you to do is I want you to I want you to do number 2 as well here with your calculator, and I want you to interpret. I want you to look at this now because we're a function of x over a function of x. I want you to interpret that that's u and that's v. Okay, do it in your calculator in number 2, come back, and then I'm going to see and look for the pattern quick first before you come back, and then we'll see if you have it right. All right, and then as you probably, oh, I didn't want to do that yet. But as you probably came in here and entered the next one, your derivative of sine x over x, you're probably like, whoa, I don't know what happened. Just so you know, you can toggle up, you can do a control copy on that, and then come down. You can go to your menu, algebra, your fraction tools, and you can get a common denominator, and I'm going to Velcro that in there. Whoa, didn't want that. Hold on. Delete. I got to come up. I need to control copy that. And then I want to Velcro that in there. And if I put that inside my get my common denominator, it just slams that little bugger together. Isn't that fancy? Okay. So when I'm looking at that, we actually had an x cosine x minus a sine x over x squared. Now this one I'm not rearranging for a reason because I know what it is. So here I got a u, here I got a v. Now, check this out. Well, the denominator really looks kind of clear. This looks like a v squared in both of them, doesn't it? Okay. And then also, when I'm looking at my sine, I also see a v there. And then when I'm looking at my, I didn't want to do that. I wanted to see my denominator, didn't I? Yes, I did, Kruger. I wanted to see my denominator. And this isn't really the way I have it memorized, but a lot of people do, and it works really well. So there's my v. Okay. And then from there, notice both of these are minus. Okay. What the heck is this 3? What's that 3? Huh. Well, that looks like it's u prime. What's this cosine x? Derivative of sine is cosine x. That looks like it's u prime, and those are multiplied. And then over here, where's this? What's that 3x? Oh, that 3x is my u. Well, what's this cosine x? Well, what's the derivative of sine? That looks like a v prime. Okay. Well, what do I get over here? Let me get rid of those minuses again. I'm just going to leave those there, though. So, what's that sine x there? That sine x, that would be a u, wouldn't it? But up here, this one has a v prime. Where's my v prime? Well, what is the derivative of x? Oh, it's 1, so there really is a v prime in there, okay? And there's a minus between there. There's a minus between there, okay? So what does it look like? I have u prime times v. Here I have v times u prime. The order, 2 times 3 is 6. 3 times 2 is 6. The order in which I multiply does not matter. This side, I have u times v prime. Here I get v prime times u. It really doesn't matter the order in which I multiply. But notice they are both subtracted from each other. And notice what happened to the denominator. Okay? So let me come to the next page here. Let's look at this here once. Let's see if this works. This is going to equal. So, if this is u and this is v, didn't we take v and square it in the bottom? And then we had a v in the top with a minus there. Okay? So then if this is my v squared, here's my v. What else did we have in there? Well, didn't we have a u prime there, so a 2x. And then I had a u on this side. So here's my u prime, here's my u, and then over here I still needed my v prime on that side, so the derivative of sine is cosine x, okay? So basically, when I'm looking at this, okay, I'm going to fast forward for a second in your note sheet. When I'm looking at this, denominator squared denominator, okay? And then I have to start differentiating. Let me come forward here. let's look at this. So if I have a function of x divided by a function of x, my derivative is going to be the denominator squared with a denominator in the top. Notice they both had a minus, okay? Denominator squared and then a denominator in the top. Then I have to start differentiating. So if this is v times x, I need a u prime on the top. Yeah, can't keep your notation right, Kruger. Okay, this is going to be a u of x, and then I have to start a u prime of x. Then I have to take it, and this other side, I just flip-flop it. V prime x times u of x, okay? And the order in which either one of these is listed does not matter, okay? And the way I think about it is, okay, I think about it as, I know it's over the denominator squared, but I think of it as the derivative of the top times the bottom function minus the derivative of the bottom function times the top function for my quotient rule. Well, let's give it a shot back here once on this other one. Let's see what it says. Well, that means y prime equals. Some people might like it like this. Some people might like to say denominator squared times denominator. Okay? And then inside there, I'm going to have two things. So I have denominator squared denominator. That means I need derivative of numerator. Derivative of cosine is negative sine x. And then I have my cosine x times the derivative of the denominator. That would be a 10x. Well, now what I'm going to do is I'm going to simplify this a little bit. That's going to be negative 5x squared sine x minus, right, 10 cosine x all over 25x to the fourth. Now I'm going to go on a whim here in the calculator. I'm going to go on a whim here and I'm going to say that is not going to be my answer my calculator is going to give me. And I'm going to give a menu, calculus, derivative in terms of x. Let's get our control divide for our fancy fraction. And we want cosine x over 5x squared, right? What do we get here? That looks pretty ugly. Looks like I need to come up here and I need to control copy that. Okay. Then I'm going to come down here and I'm going to say menu, algebra, fraction tools, get a common denominator, Velcro that little bugger in there. X cosine x minus sine x over x squared. Well, that looks a little odd. It's a little odd because it didn't copy for me. That is not what I wanted to put in there. So I'm going to come up. Come on. I want to come up. I'm going to delete that out. I'm going to come down. Okay, control, command, copy. And then I'm going to get my algebra, fraction tools, common denominator. There, I got the right one in there. Now I'm going to hit enter. Okay, check out what it says there. Okay, that's negative sine x minus 2 cosine x over 5x cubed. Why does mine look different? Here's why mine's different. It's a fraction, okay guys? Just remember this is a fraction. And fractions should and will be simplified. And I do have an x on that little guy there. I dropped my x, okay? Now if I look, I have a common factor of 5x in each numerator, and if I want to take out the negative, I can take out the negative, but it really doesn't matter. And that's going to leave me x sine x, and that's going to give me, I'll leave my negative in there. just because I'm going to cancel out my whole common denominator. That's a 2x cosine x over 25x to the fourth. Okay, so I can see the 5 reduces that to a 5. That x reduces that to an x cubed. So where I'm really at, if I grab my eraser and I really get rid of that, there's what I got, which is precisely what I have there with the numerator just flip-flopped, okay? So it's the same thing. The other way you can look at this, I hit the wrong button, is if you've had me in the past for Algebra 2, I have my little thing I like to call my happy bunny ears. If I can reduce that and that all by the same number, which I can take a 5x out of each one, and when I take the 5x out of that, I get negative x there. When I take 5x out of there, I get 2, and that x is gone. Yeah, let's get rid of that. That x should be gone. And when I take a 5x out of the denominator, I should have 5x to the third. Okay? So let's do a few practices here. So what we're going to do is we're going to do 2 practice problems. Then how some people are going to like this, they're going to want to say y prime equals. Here's how Mr. Brugink did it. You can take it for what it's worth. He said denominator squared with a denominator here. And he didn't write it there. He always wrote it first. And then I'm going to give you my pattern for the other one. And I don't care how you do it. Cosine x, and then he put a minus. And then he said, I have to multiply times that because I know there's 2 pieces. So if this was the denominator, inside the parentheses he had to take the derivative of the numerator and then put the numerator in the second one and take the derivative of the denominator. That's kind of wordy for me. It's kind of, so y prime actually equals 8x cosine x minus 4x squared sine x all over cosine squared x. Okay? That's where we're going to get there. I don't like my patterning out that way. This is the way I like to do it. I think of this as the top. Obviously, this is the bottom. And when I do my patterning for the quotient rule, I say y prime equals, I know I have a fraction, and I say derivative of the top, derivative of sine x is 3 cosine x times the bottom, x to the third, minus the derivative of the bottom, which is 3x squared, times the top, 3 sine x, all over the bottom squared. Then I clean it up a little bit, and I'll say 3x to the third cosine x minus 9x squared sine x all over x to the sixth. I will always look and see if my bunny is happy. And it sure looks like I can take a little something out of there, doesn't it? It sure looks like I can take an x squared out of everybody. So y prime should be equaling 3x cosine x minus 9 sine x all over x to the fourth. Okay? And that's how we want to keep it. We're going to be setting these little buggers equal to 0 and finding horizontal tangents and all kinds of stuff. Little practice here. Okay? 9 times out of 10, you will not use the quotient rule to differentiate number 1, but you have to right now because you do not know the chain rule. Okay? So we need to say y prime is going to equal derivative of the top is 0 times the bottom minus the derivative of the bottom times the top, all over the entire bottom squared. Never multiply out the denominator. Leave it like that, okay? What's this going to give me? Well, that's gone. I get negative 15 over 3x plus 7 quantity squared. That's what y prime equals. Why don't you try the next couple here, and I'm going to come back on with the answers. Okay, if you watch my pattern here, Kruger goes derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. Then what I do is, because you can't leave it that way, you need to distribute. You need to distribute and multiply there, okay? Then you're going to get 2x cubed minus 8x minus 2x cubed. Check it out. I can reduce up there a little bit. What does that do? That takes me to negative 8 over x squared minus 4. Notice I never multiplied out the denominator. I did expand the numerator, okay? And sooner or later, we're just going to factor the numerator. But the next one, as I came along, here it is. Derivative of the top times the bottom function minus derivative of the bottom times the top, all over the bottom squared. What I did was I distributed there, and then I distributed here so that I could collect like terms, and I can see, those go away. Minus 2x squared plus 4x squared, that's 2x squared over 4x, or over x to the fourth. I can reduce these, and I get 2 over x squared is what y prime is. But as you're going through these, ladies and gentlemen, I really want you to see, as you're cruising along, you will not continue to differentiate like that for the crappy PA on interruption. But notice I have a monomial denominator, meaning I have one term in the denominator, and this is a strategy that we'll use in differentiation as well as integration in the future. We can totally redefine this function, okay? I can say, oh, that really came from x squared over x squared minus 2x over x, okay? Mental math. I'm quickly going to jump that to 1 minus 2 over x. I would go to here. And then I would kind of be like where I was 2 days ago and say, whoa, I really have y equals 1 minus 2x to the negative 1. Notice, that's not a function of x, and it's just, or the numerator is not a function of x, I should say. And it's just over an x to an x, raised to the first power. So I can rewrite that with an exponent. So y prime is really, the derivative of 1 is 0, and then negative 1 times negative 2 is plus 2x. Drop your power 1. Look at that. 2 over x squared. And it's just a lot easier to get without the quotient rule. And this is identifying, some algebra that you've learned throughout the past years, okay? So why don't you give number 4 and number 5 a shot? Now notice again, let's redefine that little guy. Okay, I do not need to use a quotient on that. I can, but I don't have to. Go do that one and do the next one. So after you rewrite that little bugger so you can use the power rule, you just take your negative 2 times 7, negative 14x, drop the power 1 to the negative third, rewrite it without a negative exponent, and you got it. Look at number 5 though. Number 5 is a nice function of x and a nice function of x. Must use quotient rule here, okay? So what we're going to do is we're going to take the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. Then I'm going to collect all my like terms in the numerator, okay? I'm going to distribute, and I'm going to put my like terms together. And what I do see is these two are like terms that are going to get put together to not have 4. Well, that's kind of dumb. I got 2 of them there, right? 4 minus 2 is 2. And I get 2x squared plus 2x plus 4. Notice again, I did not expand the denominator. You never want to. because the whole point of finding derivatives are to find horizontal tangents and such, so we will be solving these equations, okay? Now, this next page here, u and v are differentiable functions at x equals 2. So basically, they're telling me the ordered pair 2, 3 on the original function, and u prime of 2 means the slope at that point on the original function is 4, okay? But notice they're not giving me a function. They're not giving me a function, and they want me to figure out what u times v is, the derivative of u times v. Here they are finding out, do you know your properties? Big fat question. Do you know your properties? Well, guaranteed these will be on the AP test. These should be gimme points. These should be super easy. Now, u and v are differentiable functions of x. Well, what was the derivative of a function of x times a function of x? Wasn't it the derivative of the first term times the second term plus the derivative of the second term times the first term, okay? Sometimes a lot of this makes a little bit more sense if you arrange it in your head like this and you use u of x times v of x, okay? And the reason I say that is because I would take the derivative of the first term times the second term plus the derivative of the second term, x, the derivative, y prime, that's not y prime, it's going to be v prime of x times the first term, which is u of x, okay? Notice, they want me to find at x equals 2. Notice, I'm going to come back and I'm going to say, what is u of 2 times the derivative of u of 2 times v of 2? Well, that's u prime of 2 times v of 2 plus v prime of 2 times u of 2. And then I just got to come back up here and I say u prime of 2. What was u prime of 2? Oh, it was negative 4 times v of 2. V of 2 is 1 plus v prime of 2 is 2 times u of 2, which is 3. So this gives me negative 4 plus 6, which, okay, it's 2. That's what it is. So they're making you use your properties as functions of x. They're giving you limited information to find these values of these products. And it doesn't have to be a product. It could be a quotient, okay? So if it were a quotient, okay, it's still the same thing. You can see them on yours. I got to raise my page. So I would say, what is the derivative of a function of x divided by a function of x? Well, that means the derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. Okay? Think of this as u prime of 2, v prime of 2. I can put those in there. And a 2, and a 2, and a 2. Okay? So what really happens is this is going to end up equaling, what does it equal? U prime of 2. No. Yeah. Right? I can't see my top. U prime of 2. What's my u prime of 2? U prime of 2 is negative 4. So I'm taking my negative 4 times my v of 2, which is 1, minus, what am I taking? V prime of 2, which is my 2, times my 3, all over v of 2 is 1, and then I have to square that. Okay, so what is that giving me? That gives me negative 4 minus 6 over 1. Must be negative 10. Again, they're testing your properties. Just testing properties. Here, what's the next one? Now I'm taking, it's really important, u is a function of x. Okay, because we're taking the derivative in terms of x. So that is basically saying, this is a constant multiple rule. What is 3 times u prime? Actually, it usually makes more sense to students when I rewrite it this way. So we're really looking at the derivative of 3 times u in terms of x minus 2 times, I don't need my parenthesis though, I'm going to put a little dot, times v of x plus 5 times u of x times v of x. Okay, so what I do here, it makes more sense this way, to me anyway. I'm going to say, okay, my derivative is going to equal 3 times u prime of x minus 2 times v prime of x plus 5 times the derivative of a function of x times a function of x. Derivative of the first term times the second term plus the derivative of the second term times the first term. And I'm doing the same thing here. So now if I'm looking at these all, you know, what is it at 2? Well, I'm envisioning all these functions of x are explicitly at 2. And notice they're giving me all of those values. Okay? So I have, what is this? 3 times, what is my u prime of 2? Negative 4 minus 2 times 2 plus 5 times, okay, now I redid this whole thing, but we did u times v in the previous page there, up on 6a, and we found out this whole thing here is 2, so I'm just going to jump to that for a time saver. So this should equal, what? Negative 12 minus 4 plus 10. Looks like that's negative 6. Okay. Now, this guy here, when you run into one of these on the AP test, which you will, it's really important that I'm taking the derivative of x, where u is a function of x. I have to use the quotient rule here. Because what this is going to do is it's going to give me my bottom squared. So what am I going to do? I'm going to take the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Well, now I'm going to go back and plug them in. Well, this first one doesn't matter because 0 times whatever that is, that's gone. So I'm going to have 0 minus what is the derivative of u? And again, they're asking us at 2. So I have negative 4 times 5, and this is all over 3, which is squared. Well, this is 20 over 9. Okay? And it's just, do you know your derivative properties? Do you know them? They're like little shortcuts. They're like little quickies. Now, here's what I'm talking about. Know what you're taking the derivative of. If it was d dx 5 over x, I would rewrite this function because the derivative is my x. I would say, what is the derivative of 5x to the negative 1? But notice over here, I'm taking the derivative of x, and u in the beginning was defined as a function of x. So that's why when I take the derivative of that, that's why I'm calling it u prime. Okay? Very last one here. Find the equation of the line tangent to f of x. Right there. All right, at x equals 1. What do we need? Point. And our point is quite simply going to be f of 1, and we need slope, which is going to be f prime at 1. So f of 1, well, all I got to do is take my function here, plug a 1 in there, and I have 2 plus 1. Oh, it's 3, so I'm at the point 1, 3. What is f prime of 1? Well, before I can find f prime of 1, I need to know what f prime is. So f of x, I'm going to redefine this because I'm taking the derivative of x and I'm in terms of x. 2x to the negative 1 plus x. So f prime of x equals negative 2x, drop it a power, plus 1, which means my f prime of x equals negative 2 over x squared plus 1. Then I'm going to use this to find that, which is going to be negative 2 over 1 plus 1, which equals negative 1. Therefore, m equals negative 1 at that point. So, y minus 3 equals negative 1 times x minus 1. You don't need that 1 there. You guys know by this class. You don't need the 1, you just need the negative sign. Okay? That is a negative 1. Okay? That does it for the quotient rule. Do a little practicing. You can get the rest of that book work done. Feel free to work on the J1 worksheet if you want. Those of you that are going to be at school tomorrow, you're going to have time in class to work on it after your formative assessment that you will take. That should take about 1 to 1.5 mods, and then it's work time. I look forward to seeing you guys tomorrow.